Picture a void so vast, so ravenous it swallows light, time, and the very fabric of reality. A monster lurking 18 billion light-years away, with a hunger that devours entire stars for breakfast. This isn't the stuff of sci-fi nightmares. This is TON 618, the supermassive black hole powering the brightest quasar in the known universe. Its mass? A staggering 66 billion times that of our Sun. Its light? A blinding 140 trillion times brighter than our star, outshining entire galaxies with a single ferocious glow. Buckle up, stargazers, because we're about to embark on a half-hour journey into the heart of a cosmic titan that makes every other giant in the universe look like a speck of stardust. TON 618 isn't just a black hole. It's a galactic thriller, a riddle wrapped in a mystery, and a beacon rewriting the rules of cosmic enormity. Let's start with the discovery that put this beast on the map. Back in 1957, astronomers at the Tonantzintla Observatory in Mexico were scanning the skies for faint radio signals when they stumbled across a peculiar dot. They catalogued it as TON 618, not knowing they'd found a quasar, a cosmic lighthouse powered by a supermassive black hole at its core. Quasars are the universe's heavy metal concerts, blasting energy across billions of light-years. And TON 618 is the headliner. To grasp its scale, imagine our Sun, a star 1, 4 million kilometers wide, big enough to fit 1 million Earths inside. Now stack 66 billion of those suns together, and you're still just scratching the surface of TON 618's mass. Its event horizon, the point where not even light can escape, stretches billions of miles. Wide enough to swallow our entire solar system, from the Sun to Pluto, with room for a few neighboring stars to boot. If you were foolish enough to pilot a spaceship toward it, you'd cross that invisible line and vanish into a realm where physics as we know it breaks down. Time itself would slow to a crawl, thanks to Einstein's relativity. A few hours near TON 618's edge could equal decades back on Earth, making it a natural time machine, though it's a one-way ticket to nowhere. But it's not just size that makes TON 618 legendary. Its quasar, a swirling disk of gas and dust spiraling into the black hole at nearly the speed of light, generates so much heat and energy that it outshines 100 Milky Way galaxies combined. Our galaxy, with its 100 billion stars, is a mere candle flicker next to TON 618's cosmic bonfire. This quasar is so bright that, even 18 billion light-years away, we can detect it with cutting-edge telescopes like the James Webb Space Telescope and the Chandra X-ray Observatory, which peer into the universe's deepest, darkest corners. Here's a mind-blowing fact. The light we're seeing from TON 618 today left its quasar when the universe was just a toddler about 10 billion years ago. We're looking back in time, watching a monster that was already gargantuan when Earth was still a molten rock. And get this, TON 618's gravity is so intense it warps the light from galaxies behind it, creating a phenomenon called gravitational lensing. It's like a cosmic magnifying glass, bending space-time into arcs and rings that give us a front-row seat to the universe's early days. This lensing effect is like TON 618 flexing its muscles, showing off its power to reshape reality itself. So, how does a black hole get this big? That's the question keeping astronomers up at night, and the answers are as wild as the cosmos itself. Most black holes form when massive stars collapse under their own gravity, but those top out at a few hundred solar masses. TON 618, at 66 billion solar masses, is like a cosmic bodybuilder who's been hitting the gym since the Big Bang. One theory suggests it started as a primordial black hole, born in the universe's first moments. Picture the early cosmos, a chaotic soup of gas, radiation, and dark matter, just seconds after the Big Bang. In this maelstrom, dense pockets of gas could have collapsed directly into black holes, skipping the star phase entirely. These primordial seeds, some as massive as 100,000 suns, could have spent billions of years gobbling up gas, stars, and even other black holes, growing into titans like TON 618. Another possibility? Cosmic cannibalism. Imagine a young galaxy packed with smaller black holes, each vying for dominance. Over millions of years, these black holes merge, their event horizons fusing in cataclysmic collisions that send ripples through space-time. Gravitational waves we can now detect with instruments like LIGO. TON 618 might be the ultimate winner of this. Cosmic Battle Royale, a black hole that ate its rivals to become the undisputed heavyweight champion of the universe. But here's where it gets tricky. To reach 66 billion solar masses, TON 618 would need to consume matter at a breakneck pace. Think one sun every single day for billions of years. That's like devouring an entire solar system's worth of material every few months. Its accretion disk, the glowing ring of doomed matter spinning around it, moves so fast it generates X-rays hot enough to vaporize any planet within 1 million light years. By studying these X-rays with Chandra, the scientists estimate TON 618's feeding rate, confirming it's a glutton even by black hole standards. Yet, there's a catch. Black holes can't eat infinitely fast. Too much matter piling up creates a traffic jam, and the intense radiation from the quasar can push material away, like a cosmic bouncer saying, "No more!" This balance, called the Eddington limit, suggests TON 618 grew in spurts, feasting during the universe's gas-rich youth and slowing down as its host galaxy ran out of snacks. Even now, it's probably snacking lightly, waiting for the next cosmic buffet to roll in. But TON 618 isn't just a big eater. It's a cosmic architect, shaping the galaxy around it and maybe even the universe itself. Its home is a massive elliptical galaxy, likely 10 times the size of the Milky Way, packed with trillions of stars. This galaxy is TON 618's kingdom, and the black hole's gravity holds it together like a puppeteer, pulling invisible strings. In the early universe, supermassive black holes like TON 618 played a starring role in galaxy formation. Their intense radiation and jets of high-energy particles, blasting out at nearly light speed, heated gas clouds, preventing them from collapsing into new stars. This feedback loop helped galaxies grow in an orderly way, like a cosmic gardener pruning a wild forest. Without black holes like TON 618, the universe might look like a chaotic mess with stars forming willy-nilly. They're like cosmic lasers, stretching thousands of light years and slicing through space. Made of charged particles accelerated by TON 618's magnetic field, these jets can trigger star formation in distant gas clouds or disrupt entire galaxies. In a way, TON 618 is both a destroyer and a creator, sculpting the cosmos with its raw power. Here's another wild twist. By studying the light from TON 618's quasar, astronomers can analyze the chemical makeup of the early universe. The spectra reveal traces of ancient elements like hydrogen and helium, offering clues about the Big Bang's aftermath. TON 618 is like a time capsule, preserving the universe's baby pictures for us to decode. Now let's talk about time-bending magic. Near TON 618's event horizon, time slows to a crawl, a real-life demonstration of Einstein's relativity. If you could park a spaceship just outside its grasp, you'd age slower than your friends back on Earth. A few hours near TON 618 could equal decades elsewhere, making it a sci-fi dream come true. Though again, don't try this at home. This time dilation isn't just cool. It's a reminder that TON 618 doesn't just bend light, it bends the very rules of existence. As mind-blowing as TON 618 is, here's the kicker. It might not be the biggest black hole out there. Astronomers are now chasing rumors of stupendously large black holes. Theoretical giants with masses reaching 1 trillion solar masses, 15 times heavier than TON 618. These cosmic leviathans, if they exist, could lurk at the centers of galaxy clusters, their gravity binding millions of galaxies together like cosmic glue. One candidate is the black hole in the Abell 1201 cluster, estimated at 30 billion solar masses. But it's still a lightweight compared to TON 618. The real prize is finding a trillion solar mass monster, which could challenge our understanding of gravity, galaxy formation, and even the nature of space-time. Some scientists speculate these giants might be direct collapse black holes, formed from gargantuan gas clouds in the early universe, or even relics of exotic physics we don't yet understand. And here's where it gets wonderfully weird. A few bold theorists propose that supermassive black holes like TON 618 could be seeds for new universes. Inside their singularities, where density becomes infinite, physics might rewrite itself, birthing entirely new realities. It's a wild idea straight out of sci-fi, but it reminds us that black holes are more than just cosmic vacuum cleaners, they're gateways to the unknown. The hunt for these monsters is heating up, thanks to next-gen telescopes like the Square Kilometre Array and the Nancy Grace Roman Space Telescope, set to launch. These tools will scan the skies for faint quasars and gravitational lensing effects, potentially unveiling black holes that make TON 618 look like a lightweight. Thanks for watching.